So the location of point A is over here. And the location of point B is over here. Right? So that's where the question get interesting. Okay. Point A is straightforward. So if we were to do the first moment of it, so let's do the simple one first. Okay. Point B is a bit confusing. Can anyone tell me why point B is a bit confusing? Anyone? Anyone? Can anyone tell me why point B is a bit confusing? Maybe you all can't see it yet. I'll tell you why. Okay. So point B is close to two terminals. Terminal number 2 and terminal number what? Number 4. Which terminal should you use? Point A is straightforward, right? Point A, we have to use terminal number 1. And we know that the first moment of area cannot cross the centroid. That's why we have to pick terminal number 1. Okay, so let's do point A first. Then we talk about point B. Okay, so point A, we know there is a box beam analysis. That's where we know it's 2Q, right? So we know that this will be our width. And we are aware that this will be our depth now, okay? Because the centroid or the axis of interest is ZZ, okay? So QZA, we know that we have to, I'm going to shade the area that we're going to find. Is this whole area over here. Okay, so from here, QZ at point A, so the width is what? 10, 11. The depth is 0.5. The Y bar is 3.70946 minus, right? So it's from centroid minus by 0.5 divided by 2. Okay. So this will be equal to 3.70946 minus by 0.5 divided by 2 times by 0.5 times by it's 19.027, and this is its inches cube. Okay, so the shear flow Q at point A will be equal to our V is 5 times 10 to the power 3. Our Q is 19.027. And our I is equal to 145.98. And because it's a box beam analysis, you divide by 2. Okay, because Q go to one side and then go to the other side. So 5 power 3 times 19.027 divided by 145.98 divided by 2 is equal to 325.849. Okay, so 325.849 times 10, oh no, PSI. Okay. So now we want to find point B. Okay, now find point B. Now which terminal to use? Okay. Okay, so point B is I'll write this side so you can see better. Right, point B. Right, so point B can end in, or the terminal can be 0.2 or 0.4. So there are two terminal 2 and terminal 4 are what? Are close to point B. Right? So which one to use? Are you going to use from terminal 2 or from terminal 4? Right? Are you going to use from terminal 2 or you're going to use from terminal 4? Okay. So which terminal to use? Is dependent on the larger versus on the larger, sorry, Q over T ratio. Okay, on the larger Q over T. So if we look at terminal 4, the thickness is 0.5. If you look at terminal 2, the thickness is also 0.5. So the thickness does not matter. The thickness has been normalized because the thickness on both terminal 2 and 4 are the same. So you have to focus on QZ. Okay. So if we're going to consider consider using terminal 4, right? So we want to use terminal 4. So this is the first moment of area we have to consider if we want to use terminal 4. Okay, so we calculate. So QZ, or consider T4, right? So QZ is equal to width is 0.5. The depth, okay, so the depth is what? 2 plus by, the depth is 2 plus by 0.5 divided by 2. Okay. And then the Y bar, okay, we have to be careful. So the Y bar is from the top, okay? So now we have to do the Y bar is 8.5 minus by 8.5 minus by 3.70946. So what we have done is we have found this distance over here, right? So this distance is, so the entire depth thickness is 8.5, right? And then the centroid from the top, that's why we do the minus 3.70946, right? So this distance over here to here is 3.70946. Okay. I'm going to shift this towards the right or towards the left because I need more space. Right. Okay. Then we are going to take the 2 plus by 2, okay, plus by 0.5 divided by 2, and then we're going to multiply this by half. So this should be a square bracket. So what I'm doing down here, we know that the distance from here to here, right, is 2 plus by 0.5 divided by 2, right? So half the distance over here, right? So this is equal to 2 plus by 0.5 divided by 2, and then you multiply by half again. Okay, so that's what I've done. So indeed, it does look messy. Okay, so let me carefully calculate this out. 2 plus 1.5 divided by 2 times 1.5. So it is 1.125. I do it again. 2 plus 1.5 divided by 2 times 1.5, 1.125. Then the square bracket 8.5 minus 3.70946 is equal to 4.79054. Let me do it again. 8.5 minus 3.70946. 4.7, and then you have 2 plus by 0.5 divided by 2 equal times by 0.5. This is 1.125. So plus by 1.125. I'll do it again. 2 plus by 0.5 divided by 2, or 0.5 divided by 2 plus 2 times 0.5, 1.125. Okay. 2 plus 0.5 divided by 2 times 1. Okay. So 4.79454 plus by 1.125 times by 1.125. So it's equal to 6.654, right? 6.6549 or 6.655, right? Millimeter or meter. No, this is not meter. Inches cubed. Let me do it again. 4.79054 times by 1.125, 6.65. Okay. Right. So now, okay, we have to. So before we go there, if we do the QZ, so T4, QZ over T, or QZ over T ratio, right? So this is equal to 6.655 divided by the thickness is what? The thickness is 0.5. Okay. So 6 point is equal to 13.31. So that's for terminal number 4. Okay. So if we consider terminal number 2, okay, so QZ, so the width will be what? The width will be 10. The depth will be 0.5. Now we have to deal with the Y bar. So Y bar is 8.5, or I'm going to just directly use the 4.7. Okay, so 4.79054, right? And then so that's the whole thickness. Okay. Oh, in fact, no, it's not the same. I do apologize. So you have -2, right? -2, right? And then minus 0.5 divided by 2. Okay. So why -2? Because 4.7. So over here is 2 inches, and over here is 0.5, right? So you divide by 2. So this will be equal to 4.79054 minus 2 minus 0.5 divided by 2 times 0.5 times 10. So it's 12.703 okay, inches cubed. Okay. So 12.703. Wait, let me do it. 4.79. Okay, it's correct. Okay. So now you go the T2 is equal to QZ, okay, divided by the thickness, right? So 12.703. Then you divide by the thickness is what? The thickness is the thickness is 10 also. right? Is the thickness 10? No, 0.5. And then you divide by 2. Okay. So 12.703 divided by 5 divided by 2 is equal to 12.703 inches cubed. Okay. So by looking at this, all right, by looking at this, why we have to divide by 2? Because you have the what? You have the left and the what? And the right. Yes or no? Right. So by looking at this, we know that at point B, right? We want to look at point B, you have to use which one? You have to use T4 as a terminal. Because T4 as a terminal, sorry, this is not inches cubed. This is in fact inches squared. Or it's just a QZ over T ratio, okay? Not. Okay. So you have to use the what? Terminal number what? Number 4. It is the what? Is the greater value. Yes or no? Okay. So from here, we have our Q at point B will be equal to 5 times 10 to the power 3 multiplied by 13.31, which is your QZ over, or not 13.31. Okay, you just have to take the first moment of area. So 5 times 10 to the power 3 multiplied by 6.655 divide, okay, by 145.98. Okay, so 5 power 3 times by 6.655 divided by 145.98 is equal to 227.942. Shear flow. So the shear flow, the units. Did I write the units earlier? This is not PSI. Yeah, I'm making a lot of mistake today. Okay, so the units for shear flow is pounds, is pound inch, right? Because this is PSI, pound per square inch, right? No, force is pounds. This is inch cube. This is inch 4, so pound inch. So this is also pound inch. Okay. So you have to pick the terminal, okay, the larger value, okay, not the smaller one. Then you can get the larger shear force. Okay. What I'm going to do is we're going to take a 5 minutes break. Then we come back again. We do one more example. Okay. And then after that, wait. Yeah, then I'll go into sandwich material. Okay. Okay, we take a break. As I said, I will switch off my computer because my computer is real hot. Then we come back again. Okay.